Hi everyone, my name is Nikhil Deka and I'm currently a third year undergraduate at IIT Guwahati. For my project, I built a time series based model that mainly focuses on analyzing and predicting patterns from sequential data over the time. Choosing this project just because many real world problems like stock prices, weather trends, or demand forecastings mainly depends heavily on I can say past data. So understanding these patterns helps making us better future predictions. So let's get into the project. For the problem, I am using multiple frameworks. Like for programming language, I am using Python, and you can say Streamlight for the UI, Pandas for the evaluation, NumPy is the helper matrix, states model with which help we will load the wrapper model, and scikit-learn for the model evaluation purposes. So these all my frameworks. Let's run through my code. This is ETL pipeline. The most important part is from the ETL pipeline, we will load data from S3 bucket. You can see the picture. Uh, Let me show you. From S3 bucket, I will go to ETL pipeline. Then data cleaning inside happening ETL pipeline. Then ETS decomposition for the statistical model. Then model training, train three different model, RIMA, SERIMA, and SERIMAX. Then model saving, and then deploy with Streamlight and automate with GitHub CI/CD pipeline. So let's go through the code first. ETL pipeline. So this is init function, bucket name, raw file name, local raw file name, process directory name, everything are there. We will also help with take with both O3 to communicate with S3. Extract data from S3 with this function. We extract raw data, name as local raw file. Here we can say final data.csv. This is raw data. Date views, everything are there, but there is something missing, like the you can say dates like Monday, Tuesday, Wednesday, weekly patterns. So we have to process the data. So we will transform the data and load data locally. So after transforming, drop any null values. We need to drop views, dates. If there are error, coherence, etc., etc., everything we need to handle separately. Day of week, date, day name, etc., etc. You can see in the raw data, process data. This is process data. Here are Thursday, Friday, etc., etc. Data are appearing. Then the most important part is our ETS decomposition. You can say init function, everything are initialized there. Then load the data from the process data, load you here, and then decompose the data into seasonal patterns like error, trend, and seasonality. So decomposition happen, seasonal decompose and plot the patterns to check that if the model behave like something like something like additive pattern or multiplicative pattern. So you can see here trend, moreover similar trend, just fluctuation somewhere, but that's okay. Seasonal, the data is purely seasonal trend. And residual data is not highly skewed. There are some skewness, but we can ignore them. Then the most important part is time series model training. So here we train Serima, train Serimax, train Erima. Erima as a base model. We also know that its performance will be poor just because it will ignore the seasonal patterns. So after that, we need to hyperparameter tuning. Hyperparameter tuning and evaluation done in one phase here, just with MSE. You can say mean squared error. Just be mean squared error. If average mean squared error become less with the base course of our hyperparameter tuning, then we keep that as our base core and base configuration. I am saving this in a picture. Let me show you. So here you can see hyperparameter, best arima parameters. It's poor, best core is poor, but best arima parameter is this, and best arimax is this, similar. So here we got an important pattern, like seasonality is the main fluctuation point. That exogenous variable is not affecting the data anymore because there is no exogenous variable present in the data. So you can see, let me show you. Yeah, Arima performs the worst. just because it ignores seasonality. Everyone knows. It suggests that most of the useful information is already present in the internal seasonal patterns. Yeah, no exogenous variable is affecting our main data set. So for the evaluation purposes, you can say in hyperparameter, I use mean square error, and that will be enough for the a data set less than you can say 10,000 of records. That will be enough for this project purpose. Everything will be logged there, and model saving is also done with save model as an pkl file and the load model as an pkl file that will give us the predictions. Now the most important part, models you can see arima initial, arima tune, serima initial, serima tune, serimax initial, serimax tune, everything are there. App.py with this and streamlight you can say and streamlight interface, it will serve the model and given useful user interface. So this is the code and the main function define main. This is the main entry point of that entire function. Everything will run inside this function. Yeah, that's it for the code. And the most important part is the project shows how time series forecast improves when we can say move from simple models like Arima to more advanced like Serima and Serimax. It also demonstrates how combining statistical modeling with cloud-based data pipelines result in a more practical and more near industry-based projects. So these models limitations are there also. This model assumes that future patterns will follow past behavior, so they cannot predict sudden unexpected events like if say tomorrow will be holiday for you can say Durga Puja for 5 to 6 days. That will be not captured by these models. So also being linear model, they may miss non-linear relationships also. So for those purposes, we need to train like model someone like the transformers, you can say LSTM, GRU, etc. etc. So that will be more than enough. But since this is a more machine learning project, we are limited to this. As future works, we can explore deep learning frameworks like LSTM for better modeling. So that's it, my project. Again, you can see this. Thank you.